So in this video, we're going to do some K-means cluster analysis. There are other types of cluster analysis, including agglomerative clustering and DB scan, that we'll do in some other videos. So just a reminder from our previous video with the K-means clustering, data points are going to be assigned to the group so the data point is closest to the center of the cluster, and we're going to have to specify the number of clusters. And so we talked in our previous video about methods to determine that optimal number of clusters: elbow method, silhouette, and then we have Kalinsky-Hurwitz and Davis-Bolden. All right, so let's get to it. Let's actually do this in Python. And just a reminder that we are working through the workbooks that you can find at drstephpowers.github.io/BIA. And here we are under Chapter 9, Predictive Analytics, what is going to happen, and we are doing cluster analysis. We've classified that as predictive analytics, although many of these methods span multiple different types of data analytics depending on what question you're going to answer. And here we've put it under predictive analytics because we can identify what cohort, what group, people or events belong to, then they're probably going to behave similarly to others that are in that group. And so it helps us predict what is going to happen. From a marketing perspective, this allows us to figure out, as we get to prescriptive analytics, what we should do with that particular group, because you can start to look at, well, they all have something in common, so we can treat them as a particular group or cohort, and that helps us then strategize as to the best way to approach a particular customer based on the cohort or cluster they belong to. All right, so we're doing cluster analysis, and just a reminder, click in. It opens up here in GitHub. We will then need to open that in Colab, in Google Colab. And what you will do once you open in Colab, once you push this button, you'll need to log into your own Google Drive and save a copy so you can edit the code and run it. We're going to be using a couple different data sets in this particular example. Bargain numeric, that is the coded version of our collective bargaining survey we have discussed in other videos. Our customer relationship management database. The data is cleaned here. And then we're going to look at a new one, an e-commerce customers database that came from Kaggle. And you can find all of these here on the left. So what you should do is you should save a copy of those Excel and CSV files and put them into your Google Drive. We recommend this approach rather than just linking here in GitHub, is so that when you go to do your own analysis, all you have to do is take your spreadsheets, put them into your Google Drive, and you'll know how to access them in your Google Colab. So let's actually do that. Let's go into the version where I'm logged in. And so I'm going to import pandas as PD. I need that in order to import my databases. And NumPy is NP. That's a good idea to have it running as well, because that allows us to manipulate our databases. Once you have logged in and saved a copy to your Google Drive, what you'll want to do is run this command here so that you can connect your copy of your Python workbook to your own Google Drive. It's not connecting it for anybody else. Nobody has access to it. It's simply a matter of connecting it so that it can go get your files. Okay. So I give it a second to let it connect to my Google Drive. And then I have stored these files inside my drive in a folder called BIBA Handbook, and a folder inside that, Chapter 4 for 2 of these, because we've had them as we've been working through our Business Intelligence and Analytics Handbook, my book. And so then this new data set here I actually have stored in my Chapter 9 folder since it is specific to our cluster analysis here. So all of the first part of the code here will be the same for you. Once you get to the / after my drive, it's whatever you've named the folder in your Google Drive that has this particular file in it. And if it's a folder inside of a folder, that's what this is. Then we need the name of the file, and the first two have XLSX extensions. The one that's called CRMC clean, it has multiple tabs or sheets in the spreadsheet, so we need to specify which sheet has the data. And for the new e-commerce data set that we're going to be using, it's actually a CSV file. And so we need to do read_CSV and make sure the extension says CSV. All right, let's load those in. All right, so let's start off with a graph. We're going to use Seaborn to do a scatter plot. Remember, there are lots of different methods for scatter plots. We've looked at a number of them in our videos. Let's just use Seaborn for scatter plot here. And we're going to import matplotlib as MPL. We've talked about this before. This is simply so we can make the dots in our scatter plot bigger. And then we're going to import matplotlib.pyplot as PLT so that we can actually do the plotting. So these are our packages we'd want to import. And then we also have here where we're calling this matplotlib, and we're just changing the size of these dots here to be a bit bigger. So if you're okay with the size that the scatterplot dots are, you can leave the code as is. We're setting our marker size to be 10. Then when we do our scatter plot, our x-axis here is going to be question 4 from the Customer Relationship Management database. And question 4 is the projected value of the contract. So in this case, while we're gathering information about potential clients, we're looking at, well, based on their needs, how much would the website we build them and the services we do for them be worth? And then how much is their company worth in terms of company revenue? And that's question 2. Okay, we'll put labels on this graph. The X label we'll call projected value of contract. The Y label will be company revenue, and then we'll show the plot. So here we have all of the different companies that are potential clients for our business, and we're looking for cohorts, groups, clusters of them, so that we might figure out how to target different types of customers, different groupings of customers who have different needs. So likely we can easily see that this is probably going to be a cluster. These are large companies that are going to need a lot more in terms of their website. And then we have much smaller companies who probably don't need a whole lot or a whole lot of complicated services, and so they fall here. So then the question becomes, this group in the middle, can we discern from them specific clusters that we could then approach and target our customers differently depending on which group they belong to? So to do cluster analysis, we're going to do KMeans clustering. This is from sklearn.cluster. We're going to import KMeans. And using the numpy that we had imported a moment ago, we are going to create an array. So we have to have it formatted a certain way for these types of packages. And so here what we're going to do is we're going to take question 4 and question 2 from our data frame 3, and we're going to create an array. So just to show you what that looks like, if I just say X here, what you see is that we have these pairs of question 4 and question 2, and they are then comma, the next pair, the next pair, the next pair. So it's formatted this particular way in what is called an array, and that is simply because that is what our package, our KMeans clustering package, is looking for. So to do our KMeans clustering, we call KMeans, and we need to specify the number of clusters. And so we could look at the data initially, our data visualization, and say, okay, well, maybe there's about 6 clusters here, maybe 1, 2, 3, and then maybe this can be broken down. Okay, we'll start there, and then we'll use our methods we talked about in the previous video to assess whether there's a better number of clusters. So we're going to call this KMeans. We're going to call the actual function KMeans, and we're going to specify the number of clusters equals 6. Okay. Then what we're going to do is, just like with our classification models, after you call it, you have to fit it. The difference between our classification and our cluster is because classification had labels, we separated the data into a testing set and a training set. With cluster analysis, since it's unsupervised learning, we don't have the labels, we don't do that separation into test and train. Okay, so we're simply going to fit our model against our data. That is this array that we've created here. That is those 2 variables that we're looking at. We can then call from KMeans, so we name this KMeans. We can then have it output the labels that it's attached. So if we do that, what it shows us here is it shows us that for our data set, the first data point, which if I scroll up here and look at this array, keep scrolling the wrong thing, but you know, the second I scroll the other thing, it's going to be way out of the rack. Okay, so the first one here, 941, no, it's not the first one. First one, 8790 and 288389. So this is going to be a data point that's down here in our chart. So they're not going to need a lot for their website, and the company is on the smaller side. So when we look at how it classified it, okay, it put them in group 3. And then we could keep going through, and you can see here there's a group 0 and a group 1 and a 2 and a 3 and a 4 and a 5. Don't forget, Python starts its counting at 0. So if you ask for 6 clusters, you get 6 clusters with 0, 1, 2, 3, 4, 5. Okay, so 0 through 5 gives us 6 clusters. So you can see how it's clustered. Well, you know, great. That's a bunch of random labels there. What's better is to graph it. And so with our cluster analysis, what we want to do is we want to create that scatter plot again. So from Seaborn, import scatter plot. You technically don't need to import this again because we just did it before. But just in case you forget, import matplotlib as MPL. That was so we could change the size of the dots. Import matplotlib.pyplot as PLT so that we could do the graph. Notice here, we're going to add to our graph a hue. And our hue is going to be these labels. So we said KMeans.labels, and we said CL for cluster. And so where right here we have hue equals CL. So this label, or this name here, needs to match that name so that it will color code the labels onto our scatter plot. The rest of this is the same. The x-axis is question 4, the y-axis question 2, same x and y label. The palette equals deep here. That's just whatever color scheme you want. There are other color schemes. Simply Google Seaborn scatter plot palette and it will give you lots of choices. Okay, so here's what it looks like. We have, here's blue, here is group 0. Here up here in orange is group 1. And then we can see here is group 2. And we have our 6 groups. So we have done some cluster analysis. The question was the 6 clusters the appropriate choice? We can see, you know, it makes sense that this is a cluster. It makes sense that this one's a cluster. It makes sense that this one's a cluster. What about this? So to see if we really did pick the optimal in terms of the number of clusters, we first look at the elbow method. To do the elbow method, we are going to create a loop. So recall back to our videos where we talked about how to build a loop. So to do this, let's start with an empty list. We'll call WCSS. Okay. And that's because that's what this actually measures when you do the elbow method, but you can call it whatever you want. Okay. All right. So for K in range, now I just chose K. You can call it I, you can call it whatever. You can call it for cluster in range 1 to 10. So K is just a placeholder. Now the range is going to be 1 to 10. That's just a range that we've chosen here. That means that it's going to include 1 and go up to, but not including 10. We had started with 6 clusters. And so we want to go lower than that, and we want to go higher than that. So you can decide how many different scenarios you want to consider. Just recognize that the longer the range, the longer the loop takes to complete. So what you're doing is essentially repeating the steps we just did, where you are doing the K-means, where the number of clusters is equal to K, or whatever letter or word you're using as a placeholder here. And so it's going to go through and it's going to do K-means where the number of clusters equal 1. Then it's going to do a number of clusters equal 2. Then the number of clusters equal 3. All the way through. Each time it's going to fit it on our data set. Okay. And so in order for this to work, we have to have already defined X. And recall from our work up here that X is that array that is the 2 variables we're using to cluster. Okay. Now, we just happen to be using 2 right now for clustering because you can see it nicely on a scatter plot. You can cluster with more than 2 variables. We'll look at how to do that a little later. All right, so let's go back to our elbow method. The other thing, as we were learning our coding in Python, we talked about append. And so what we're doing is as it goes through this loop, it is going to keep an output from KMeans called inertia. So we call this lowercase KMeans. So that's what it's doing, is it's doing this KMeans where it fit the cluster analysis. And then one of the outputs from that is something called inertia. And so we're going to have that inertia be collected and appended for our information here. Once we've gone through that loop, we then want to plot that. So we're going to plot that range of 1 to 10. That's what's going to go on the x-axis. And then on the vertical axis is going to be this inertia that we're collecting, this measurement that's used in the elbow method, and we're going to mark it with a dot. So the x-axis is going to be called number of clusters, K, and then our y label is our WCSS, and we'll title this elbow method. Okay, and we'll plot this. So in order for this plotting to work, we of course have already had to import our matplotlib.pyplot for it to function. Okay, so what we get is an image that looks like this. And as we had said in our previous video, we'll just go back. So our elbow method, when we're looking at this measurement here, we're looking at how far data points are from the rest of the cluster. And we want the number of clusters just past the curve on the elbow, right where it starts to straighten out. So in this example, the ideal number was 4. Let's go back to our image here, and it is that same image. So we can see here that we'd probably want to have 4 clusters. So you want that point where it just starts to straighten out after the curve, the turn, the corner of the elbow. Okay. So this says, okay, well, 4 is probably the ideal number. So then what we can do is let's rerun it with just 4. So we'll do KMeans with a number of cluster equals 4, fit that with our data, and then find the labels, and then put the labels on the graph by having those labels be the hue in our scatter plot. So when we do that, you can see that this whole group here is identified as one cluster. Now, when you do cluster analysis, the next step would be then to look at that particular group. What do they have in common? What do we know about them? Perhaps give them a name. And so then we can start to identify that that group has common similarities. And so in our decisions we make for our organization, we would then treat those as part of a similar group. Okay. Now, another way we can look at this, so this is a bit of a crazy code here. So what this is going to do, I'll just go to the end here, is that this is going to show you how it's breaking the different clusters, and our X showing you the center of the cluster. So remember with KMeans, what we're doing is we are looking at, we're assigning to the group so the data point is closest to the center. And so you can actually create a visual that shows you here's the center of the cluster. And so these data points were all allocated to this particular cluster because they were closer to this X than they were to this X. So in this particular case, you'll notice that they're kind of horizontal lines here because it's saying really what's most relevant for the grouping is the company revenue, not the value of the contract. Otherwise, there would be an angle to these lines. So here we have our different clusters and the center of them and essentially how it's splitting them, which means then when you have a new data point, a new company that's been identified as a potential customer, you can look at their projected value of contract, you can look at their company of revenue, and we could put them into a particular cluster based on this information. So you can actually kind of use these points as cutoffs for how the clusters are being defined. So to create a graph like this, you really can take a lot of this code just as is. Okay. So what we're setting here is we're setting a lot of the boundaries of the graph itself and creating what is called a mesh grid. And then we are going to arrange that grid so that we have x min to x max, y min to y max. Okay. And then it's going to do our K-means predict. And again, we're just reformatting, reshaping the information. We are plotting it. Okay. This IM show we're going to use as we graph our linear programming information as well. But this is really all just formatting to get you to this image here, which means you don't have to change any of this when it comes to it, as long as you have defined, where's our data here? As long as we've already defined our X. So remember, that was the array that we had of our original data set that allowed us for this. So this grid is only going to work when there's two variables in that X array. And you can see here how it's setting the boundaries of this grid here based on X. So if you call it, if we go back, if you call this here, I keep getting stuck on this one here. So as long as you call this X and there's only two variables here, then when it comes to this visualization that shows you how it's breaking, you can leave all the code as is and just hit run, copy, paste. So all it's doing is taking those X's, using that to create this mesh grid, and then it's putting those X values on top of it. It's taking your cluster analysis that you previously ran and put it there. So you don't have to tweak it or really worry about the complicated code that you see here. It's all just formatting to get it to put colors and X's onto that scatter plot you had before.